Hey YouTube, welcome back. Geographic redundancy. Geographic redundancy refers to the practice of deploying multiple instances of critical systems data or service across different geographic locations to ensure high availability, fault tolerance, and disaster recovery. If one location or data center experience failures due to nature disaster, hardware malfunctions, or network outages, another geographic distant location can take over, allowing the system to continue functioning without significant downtime. Geographic redundancy is often implemented in cloud computing data centers and mission critical applications to ensure continuous availability even when one location is compromised. So let's take an example for that. Let's say that we have a client here, okay, and this client is sending requests to a load balancer, and the load balancer, as always, will distribute the incoming requests across multiple services. Okay, let's say that we will apply. Let's say that this is one. Let me delete this. This is one, and this is two. So if we want to make a geographic redundancy, let's say that we will put this as one in Germany, like DE for Deutschland, and another one in France. So let's talk about what did we applied, or what did we established, or what we are getting from this. The first thing, we can have disaster recovery. Like if one location, let's say the DA, experience a disaster like earthquake, flood, explosion, whatever it will be, the backup system in another location can take over. So if the client trying to send the requests and the load balancer is distribute all the incoming requests, for example, of any client in Germany to the server in Germany, this server went down, the load balancer right now will redirect all the incoming requests and will make sure that the server in France will serve it. So we can handle this disaster recovery. The second thing, load balancing across locations. Like traffic can be distributed across multiple geographic regions for better performance, reduced latency, and load sharing. For example, the users in Germany, as we said, can be routed to European data center that is in Frankfurt. So it will be way more quicker than reaching a data center that in France, for example. Let me delete all of that. Okay, yeah. Number three, we have fault tolerance. Basically, by duplicating critical system across different regions, the system remains fault tolerant. If critical system fails in one location, the redundant system in another location continues to operating and take its working. So again, if the server in France, we have a fault tolerance. So if this one failed, oh no, if this one failed, this server could take place. Also, I guess if we are talking about fault tolerance, we're talking about disaster recovery. I guess we are also talking about failover mechanism. Like in the event of failover mechanism or failure, in the event of failure, automatic or manual failover mechanism redirect traffic and and operations from the affected locations to the backup location. So by saying we have a failover mechanism. So when the server fail down, the load balancer basically will have a failover mechanism and it automatically will redirect all the requests that should go to the server, the DE server, to the FR server. Okay, so let's talk about where actually we will use geographic redundant. Number one, it will be in cloud computing and infrastructure. Cloud computing and infrastructure and infra. Like Amazon Web Server, Google Cloud Platform, and Microsoft Azure all offer geographic redundant services where applications and data can be deployed across multiple regions. Each cloud provider has multiple availability zones and regions designed for high availability and disaster recovery. The use case for that it's like e-commerce website hosted on AWS that may need multiple AWS regions. Also, geographic redundancy it's used a lot in CDNs. CDN it's a content delivery network like CDN such as Cloudflare or Akamai use geographic distributed servers known as edge servers to catch and serve content closer to the user, ensuring fast content delivery and reducing latency. Also, it's used in financial institution. So banks and financial institutions use geographic redundancy to ensure continuous access to critical systems such as online banking, ATMs, and payment processing. It's used in data centers, and this is quite big one. We should talk about it. Data centers. Large scale data centers use geographic redundancy to ensure continuous operations even during regional outages by replicating critical services and infrastructure across different locations, and they will avoid complete service disruption. Um, there are a lot of things where we use actually the geographic redundancy, and we said that benefits is that we have this disaster resilient, we improve availability, we reduce latency because by doing a geographic redundancy, if we have a client that from the DE from Germany, we will redirect it to the server in Germany. So this will be way more quicker than going to the server in France, for example. So we reduce latency by this one. By hosting services in multiple regions, systems can serve users from the nearest location, reducing latency and improving performance. We have a global reach because geographic redundant systems allow organizations to provide reliable services to a global audience by ensuring that services are always accessible regardless of regional outages or failures. We protect our data as well because we use data replication across regions, protects against data loss caused by catastrophe failure or corruption at one side. So if the data in server one, if server one failed, we actually replicate all the data to server two to make sure that we protect our data. There are some considerations in the geographic redundancy. One, it will be the cost. Implementing and maintaining geographic redundant systems can be really expensive. Costs including infrastructure, data replication, bandwidth, and failover management. Number two, data consistency. Ensuring data consistent data across geographic distributed locations can be challenging. Like asynchronous replication can lead to slight data inconsistency, especially if failover occurs before data synchronization completes. There's also really complex failover management. With the geographic redundancy, the failover management become even more complex. Failover complexity. Let's just say so configuring and managing automatic failover between geographic redundant locations require careful planning, automation, and regular testing, ensuring that systems can switch over seamlessly without data loss or service disruption. Can be really complex. Also, we have latency in replication, and also there is another problem, which is the testing and validation, because regular failover testing is necessary to ensure the system works in intended during real outages. However, such tests can be quite disruptive and require coordination across regions. So, in conclusion, geographic redundancy is critical strategy for organizations aiming to provide high availability, fault tolerance, and disaster recovery across distributed systems. By deploying systems, data and services across different regions, organizations can protect themselves against regional outages, natural disaster, or other failures. This approach ensures continuous server delivery, improved performance through load distribution, and enhanced data protection while it introduces costs and complexity. Introduces cost and complexity. The benefits of geographic redundancy far outweigh the risks for mission critical applications and services. So that's it for this video, and see you in the future.